All right, boys and girls, welcome back to the drive-through. As we're getting to this, they're getting more and more difficult, okay? So this is help with number 10 from section 6.1. We're going to need to figure out how to space our graphs so that we can graph each one of these. So the first thing I'm going to do is copy over all my equations. Okay, so we've resumed the video, and now we've put in each of the equations from these tables that you did in sections 8 and 9, okay? Before we get going on this, I would really like to show you the difference between an exponential, a quadratic, and a linear. So I'm going to go over to Desmos and type those three in separately. So we got y equals 1 times 2 to the x power. Whoops. Okay. And then our second equation was y equals x squared. And our last one was 2x minus 3. Is that right? So you can see, that the curves coincide with the colors. Notice that the quadratic one is always positive. Why is it always positive?
Because you can't, because that's always, well, here's the thing. If you multiply a negative, let's say you have negative
That's
1,
right. Because a negative times a negative is a positive, okay? So if you put in a negative 4 for the blue equation, you get a positive 16. It gets big real fast, okay? So with that being said, let's go ahead and zoom out. And now you see the red one almost looks like a right angle. The other thing that's very interesting is that when you get to calculus, you're going to see that oh, I thought the green line was tangent. Yes, it is. The green line is tangent to the blue line, and that's going to mean something to you. That means it touches it at exactly one spot. Okay? So, what we're doing is learning how to graph these by hand. The best thing you could do to graph these is to use a graphing calculator or Desmos. But by hand, we've got to figure out the scale. So, we've got to get all 6 points on our graph. I think I've got to get up to about 1,000. So what I'm going to do in A is start at 0 here. This is going to be so hard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to go up by 100. So 200... 400, I'm skipping 2 every time, 600, 800, and 1,000. Now, I'm not a big rule-following guy, but I do recognize that I'm going to be slightly off the graph there, and I'm going to deal with that, okay? So, let's see. If I put in a 6, I get a 64. So that's about a little more than half of 100. If I put in a 7, I get a 128. It's about right there. If I put in an 8, I get a 256, a little more than halfway past 250. If I put in a 9, I get a 512. And if I put a 10, I get 1,024. Okay? So now I'm going to make a curve that passes through View Frickin' Sonic. All right, I'm just going to go faster, Carson. Okay? That's the best I can do on this ViewSonic. All right, for B, I get y equals x squared, 6 comma 36. Looks like I got to get to 100 this time. So I'm just going to put a 50 here and 100 there. That tells my audience that each step is worth 10. I'm going to put a 5 here and a 10 here. That tells my audience that each step is worth 1. Okay? And then I just put them in. Give me over 6, up 36. So a little bit past the 3. Put in a 7, I go to a 49, just short of the 50. Put it in an 8, I get a 64. Put it in a 9, I get an 81. And put it in a 10, and I get 100. Okay, now, the difference between this one and this one is that, as you've seen before, that one would go back up. But they're not asking us to graph that side of it. They just want us to get all 6 of the points. So that's why I'm just going to leave it like that. So far, so good? All right, y equals 2x minus 1. Well, we can do that. Let's just change our axis to here and here. What's our y-intercept? Our y-intercept is -1. What's our slope? Okay, each one of these is worth 1. Each one of these is worth 1. Okay, I would use a straight edge, but I can't because it's ViewSonic. All right, y equals 5x minus 27. Let's just use the table. So we've got to go up. So I need to put our axes here.
Oh, wait a minute. I'm wrong. It's not 27.
No, oh yeah, 5x minus 7. Okay, so we got that equation wrong. Let's fix it. Okay? Alright, so let's just make these worth 2 then. So then this will get us up to 10 and down to 10. And we're only going over, so I think this covers it. We're going to go over by, I got to go to -17. Yeah, you're right.
What about?
I don't really like 3s. I'm just going to pick 5s. Okay? So this is going to be 25 and -25. -25. And then I'm just going to go over by 1s, right? So this is 1, 2, 3, 4, 5. We're going to end at 9. All right, let's put our points on there. So -2, 17. Whoops. -2 up 17. It'll be somewhere around here. Okay. -1. Sorry, -2, -17. Carson, my fault. -2, -17. It's going to be here. -1, -12 is going to be here. 0. -7. 1, -2. Why aren't these lining up? -17. That's the problem. Hold on. All right. -1, -12. Okay, that's kind of close. Make this point a little bigger. All right, now we're doing a little better. -2, -17 would be here. And then 2, 3 is the last one. Right there. Okay, there's that one. Let's put our axis right here and right there. This is going to be just go over by 1 each time. We got to get all the way up to 25, so we'll go up by 5. Make it look like that. Okay? So we've got -2, tiny. We've got -1, a little bit less tiny. We've got 0, 1. We've got 1, 5. And we have 2, 25. So hopefully you remember that we want our money to grow like rabbits. And so you can see that this is growing really, really fast. Whoa. Whoa. You sonic magic. All right, we're going to leave that. Finally, F. Oh, this one's not bad. We can just do these with each one worth 1 if we just do it like this. Here's our axes. My God. Okay, we'll call each one 1. So -2, 9. -1, 6. 1, 6, 2, 9, and 0, 5. So when we graph this thing, it's like a U, I think, more than a V. It's curved. It's not, doesn't have an angle. Okay? Hopefully this helps. This is a long video. Boop!